Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. Looking back to our guide earlier, the first type of factoring we always need to consider is a common monomial factoring, regardless of what type of polynomial is it. Then, afterwards, we are going to consider the remaining factors if we could factor them further. Here, 9p squared minus 4q squared is a binomial. And if ever, just if ever, we could factor out a common factor later, the resulting form would also be a binomial. And we are going to look at it whether it's a difference of two squares, a difference of two cubes, or sum of two cubes. And if if the result will not meet any of those standards, then we write the result as it is. So let's start with the common monomial factoring. The common monomial factoring allows us to take the greatest common factor for both numerical and literal coefficients. Let's start with the numerical coefficients. Here, we have 9. The other is 4. Can we look for a factor that is possible for 9 and 4? The answer is only 1. That's 1, right? But factoring 1 will not change any of these two. So we might also skip that one. So in short, we cannot look for the greatest common factor of the numerical coefficients. Let's look at our literal coefficients. P squared, Q squared. Looking at it, we don't have any common variable to both of them. Of course, the exponent is not a common value, since the exponent is telling us that there are two p's for the first term and two q's for the second term, but it doesn't mean that they are common factor. That would mean the first step, the common monomial factoring, is not possible here. With that, let's dig further. This is a binomial. So there could only be 3 instances where we can factor it further, and 1 instance where we just copy this and end with the result. So we are going to examine whether this is a difference of two squares, difference of two cubes, or sum of two cubes. The first thing you need to do is this. Look at the literal coefficients. If the exponents are divisible by 3, we're going to proceed with the cubes. But here, since the exponent of the first variable is 2 for p squared, and as well as in q squared, that's 2. So this cannot be a difference of two cubes. Of course, this cannot be a sum of two cubes because it's minus in the middle. So let's proceed to the remaining one. Difference of two squares. The difference of two squares is telling us that both terms separated by subtraction should be perfect squares. The first term, 9p squared, for the numerical coefficient, 9 is a perfect square of 3. And p squared is a perfect square of p. So this meets the criteria. Our second term, 4, is a perfect square of 2. And q squared is a perfect square of q. So this meets the criteria. So we are going to use the difference of two squares. And since we are sure of this, the factors, if our polynomials is a difference of two squares, it's with two binomials of opposite operations. So we'll have the first term here, same first term, same second term, but different operations. Of course, you could have addition here and subtraction on the other side, because multiplication is commutative. It will not change the fact that they are just the same. So let's continue. Now, we are sure again that this is a difference of two squares. So we simply take the square root of the first term. The square root of 9 is 3. Also place a 3 here. The square root of p squared is p. Also have p here. That is the process if it's a difference of two squares. Next, of course, the operations are different. Let's proceed to the second term. Square root of 4 is 2. So place 2 here as well. The square root of q squared is q. And you place it here as well. So these are the factors for this polynomial that is considered as difference of two squares. We'll have two binomials of the same first and second term, but different operations separating those terms. Of course, you could check this one using FOIL method. 3p times 3p is 9p squared. We have this here. That's negative 6pq, positive 6pq. So that's become, those two results become 0. And you have here negative 2, positive 2 is negative 4q squared. Okay, so this is now the correct process. This would mean that these factors are correct for this difference of two squares polynomial. The next factor we're looking for is for our next subscriber. Subscribe now.